Assalamu alaikum students. Today we will cover qualitative inorganic analysis, and this is the first lecture about this topic. In this topic we will cover only the first part, that is the introduction to salt analysis. That what is qualitative analysis, quantitative analysis, qualitative inorganic analysis, introduction of salt and its two components, that is anion and cation. And then we will study the scheme of the analysis and as well as the classification of cation and anions. Cations means positive ions, anions means negative ions. So you can see that these are different precipitation reaction. These are the different colors showing different precipitates that we will study one by one. So the salt analysis, that is your topic in second year chemistry, it is a part of qualitative inorganic analysis. So see now, what is analytical chemistry? It is a branch of chemistry that deals with the analysis. Analysis in Urdu it is called tajziya. It itself is difficult to understand. Tajziya or analysis means to determine how many components and what components are present in a given sample, and as well as we can determine their quantities. So in this way we have classify chemical analysis into two parts, qualitative and the quantitative part. In qualitative part we just identify what are present in the mixture in the given sample. And if you are going to determine any quantity, it can be number of moles, it can be concentration, and it could be volume. So that is under the quantitative analysis. So we will see in little bit detail in other in later slides. There is no specific there is no scientific work without analytical chemistry. So remember that if you are going to do something in your analytical chemistry, if you're going to do some scientific work, then remember that it is impossible to study it. It is impossible to carry out a scientific work without analytical chemistry. So analytical chemistry is the backbone in scientific experiments, in scientific work. Either you are performing qualitative analysis or the quantitative analysis. Now see, what is qualitative analysis? In qualitative analysis, we can identify different types of ions present in the sample. That is the part of qualitative inorganic analysis. It could be NMR that leads to determine the structure of an organic compound. These are the NMR components of the NMR setup. So we perform different experiment here, and then we get the spectra from this analysis, and we study we study for analyzing and identifying different organic compounds. Column chromatography can separate the different components depending on their different RF values, and it is a part of chromatography that is called the column chromatography. This is also the chromatogram. Another type of chromatography is the thin layer chromatography. So this is the thin layer chromatography, where we can compare different samples, whether they have the same components or not, or we can identify the certain chemicals. If we put another spot of that non-sample here, then we can compare them. But our study is only the qualitative inorganic analysis right now. Okay, so we will focus only on this qualitative inorganic analysis. Now, the another term is the quantitative analysis. Quantitative analysis you have performed in your school level and intermediate first year chemistry. Different types of titration. This is the redox titration. In titration, we determine the concentration of uh, a solution whose concentration is unknown from the given concentration of the other component. For example, here this is the iron sulfate FeSO4 and this is potassium permanganate. So if any one of them is if the concentration of any one of them is unknown, then we can determine it, and you have done it well in your first year chemistry, your intermediate first year. This is the setup of HPLC. HPLC can be of two types, and usually it is used to determine the quantity of different components in a given sample. And you have learned in your class 10 HPLC, high performance liquid chromatography, to identify or quantification of components in the given sample. This is a well-known technique in different industries, especially the pharmaceutical industry. Now, what is salt? Salt is a substance that is obtained by displacement of hydrogen from an acid by a metal. For example, if you see that this is HCl, this is a very simple reaction, and all the acids, we react them in their aqueous form. So what happens? For example, when it reacts with zinc, it displaces hydrogen and produce the respective salt of zinc. Zinc chloride is produced, and zinc chloride is water soluble, so it remains in aqueous form, while hydrogen displaces as gas. So if you see here, you should notice that uh, okay, so you should notice that this is the salt, because this is obtained from the displacement of hydrogen by a metal or metal-like ion. So this is the metal ion. This is zinc ion. So zinc ion is this, and this negative ion came from acid. Now see another example. Another example is HCl aqueous plus sodium hydroxide. Sodium hydroxide is an alkali, it is also aqueous. So this is the acid-base reaction. And what happens? Again, the same thing. This metal displaces hydrogen and it forms sodium chloride. Sodium chloride is also soluble, and so it is in aqueous state, and hydrogen combines with OH to form water. And remember that this is the neutralization reaction. This is metal displacement reaction. metal displacement reaction. And this is neutralization reaction where an acid neutralizes the base. Neutralization reaction. In most of the books in Pakistan, instead of S, there is Z. So actually, there is a difference of spelling in American and British. In British, the spelling is usually S. In American English, there is Z. So don't worry about it. So this is the neutralization reaction. If you see here, first see another neutralization reaction, for example, H2SO4 aqueous reacts with ammonium hydroxide. Ammonium hydroxide is considered as metal-like ion. This is not metal, but metal-like ion. In solution, it behaves like a metal ion. So that's why such an ion is called metal-like ion. So what happens again? This is also a double displacement reaction. Ammonium ion displaces hydrogen from there and form hydrogen ammonium sulfate. And hydrogen combines with OH to produce H2O. H2O is liquid and this is the aqueous solution. Okay, now see one more thing. That in both the salts, in sodium chloride, in ammonium sulfate, if you notice that the negative ion came from, these are the negative ion, sulfate. And this chloride is also a negative ion. In acid-base reaction, these negative ion came from acid, while the positive ions came from base. So that's why from these neutralization reactions, we can understand that the negative ion always come from acid because the positive ion of acid is hydrogen, and positive ion always come from the base as the OH always combine with the hydrogen ion to form water. So the remaining ions after the formation of water are the positive ion from the base and negative ion from the acid. So positive ions are either known as cations or the basic radicals. So these two terms can be used for positive ions. And as these ions are from chloride and sulfate, ions are from an acid, or any negative ion came from an acid. So these are called anions or acid radicals. And remember that the word acidic is wrong. If you are writing acidic radical, this is the wrong term. Acid radical means anything that came from an acid, while acidic means that has acidic properties. So as these are not having acidic properties, so we can't say acidic radical. Okay. Okay, so now you have better you have better understood about the salt, what are salt, and the terminologies from here we have got from the neutralization reactions. Now, what is salt analysis? It is a type of inorganic qualitative analysis that deals with the identification of components in a salt. What are these components? I have already told you that these components are positive ions and the negative ions. Positive ions can be called cations and basic radical. While the negative ions are also called anions or acid radicals. So you can use these terminologies, and we will frequently use these terminologies in coming slides. Now, what is the objective of salt analysis? The purpose or the objective of the inorganic qualitative analysis is to enable the acquisition of powers of observation and deduction among the researchers, students, etc. The learning of reactions of inorganic chemistry, because it deals with the inorganic chemistry. The development of skills in chemical reactions, especially at in microanalysis. This is called the microanalysis because we take very small quantity for analyzing the salt. The steps involved in salt analysis. First is the preliminary examination that gives you an idea that what could be present in the given sample of the salt. Detection of anions. The second step is that we detect the anions, and always the anions are detected first because anions gives you an idea about the cations as well. How? We will see in later slide and the later lectures. Detection of cations. After determining the anion or the acid radical, then you will study the basic radical. Then the development of the formula of the identified compound. So when you have identified anions and cations, then you are to write the formula of the identified salt. For example, if you have found that the compound has ammonium as cation and sulfate as anion. So how to write the chemical formula? So remember that first we always write the positive ions first, and it has plus sign means it is 1 plus, and sulfate has 2 minus. So one ammonium ion has plus 1 charge, and the one sulfate ion has a negative 2 charge. And we know that the compound is neutral. So definitely two ammoniums can satisfy or neutralize the charge. So this is the one way. And another way that you have studied at your school level, that these ions, which are polyatomic ions, consist of more than one atom. They are kept in bracket. This is sulfate. It is also in bracket. So the charge of one ion, for example, cation, is made subscript for the anion, and the charge of the anion is made subscript for the cation. If there is one, then we don't need to write the bracket and this number. So the formula of ammonium sulfate is NH4 twice SO4. So finally, we will identify the salt and we will write the formula of the compound as per your analysis. Now, the preliminary examination. When the salt is given to you, then you can perform some preliminary examination. One of them is the color and the appearance. If the compound is colorless, it shows the absence of transition metal ions, for example, copper, chromium, iron 2 ion, that is also called ferrous, Fe3 ion, that is called ferric, iron 3 ion, and nickel ion. These all give certain colors. So it shows the absence. So if these are these are absent, then what could be present? There could be aluminum ion, sodium ion, ammonium ion, and there is a long list. There is a long list of cations which gives colorless solution. And usually the color of the solution is observed instead of the salt. Although we can observe the color of the salt as well. If the salt or its solution is blue or bluish green, then there are more chances of copper, copper 2 plus. If compound is green, you should remember that there are different shades of green. So these could be iron 2 plus, copper 2 plus, nickel 2 plus, chromium 2 plus, chromium 3 plus may be present. But when you will perform different experiment, then you will see the difference in their colors as well. Copper compounds of copper are usually blue in color, but its chloride is green in color. So if you found that compound is green in color, then it could be any one of these. So it gives you a better idea about the presence of cation, color of the compound and the solution. If it is brown, then a few compounds of copper are brown. Some compounds of nickel are also brown, and iron itself is brown in color and gives yellow brown solution in aqueous condition. If compound is black, then there would be sulfide. There is an idea about the negative ion, but remember that sulfide is usually not performed. It is not given in most of the colleges. If compound is pink, if it is light pink, then it is manganese, or if it is the shocking pink, then it is cobalt, cobalt 2 plus. And one more important thing, if you are making solution of the salt containing manganese, it would be almost colorless. But the solution of cobalt would be pink in color. Action of heat. And some more preliminary examinations are carried out that I will discuss. Action of heat. If yellow when hot and white when cold, then it could be the compound containing zinc ion. And usually, remember that action of heat is not performed at intermediate level, but at graduation level, we perform this as well. If white sublimation is there, then there could be the aluminum or magnesium salt. And with ammonical as well, then there would be ammonia. If reddish brown gas is evolved, then there could be nitrate, because nitrate decomposes to produce nitrogen dioxide that is brown in color. If colorless gas is evolved, and turning the lime water milky, then there could be oxalate or carbonate ion. Actually, the formula of carbonate is wrong here. It should be CO3 2 minus. If chairing takes place, then there are chances of oxalate ion. This is oxalate ion. So these are the some of the preliminary examinations. And solubility, then we check the solubility. Solubility, if your compound is water soluble, then there could be nitrate because every nitrate containing salt is water soluble. Every nitrate containing salt is water soluble. And that's the reason that we use nitric acid for dissolving or removing some of the stains. Stains, if these are the inorganic one. And chloride, most of the chlorides are water soluble. So if compound is water soluble, then we can guess it could be nitrate. It could be chloride because only these chloride are insoluble. Silver chloride, lead chloride, mercurous chloride. Here, mercury has +1 charge. So the name of this compound is mercurous chloride. Bromide, similarly, just like the chloride, bromide are also water soluble. Most of the salts containing bromide are water soluble, except these: silver bromide, mercurous bromide, mercuric bromide, and lead bromide. Iodide. Most of the iodide are also soluble except the silver iodide, mercurous iodide, mercuric iodide, and lead iodide. Most of the sulfates are also soluble except the calcium sulfate, strontium sulfate, barium sulfate, and lead sulfate, mercuric sulfate, and silver sulfate. These are the insoluble sulfate, while rest of the sulfates are water soluble. So the soluble compound could be there. Now this is the chlorate. Every chlorate is water soluble, but chlorate is not the part of our study. It is not included in intermediate syllabus. This is acetate. Acetate is usually written like this: CH3COO minus. It can also be written as CH3CO2 minus. This is the acetate or ethanoate ion, and its compound are also soluble, and it is the part of our syllabus. These all are part of our syllabus except the chlorate. Now sulfide. Most of the sulfides are insoluble. So if your compound is water insoluble, then uh, you can think about negative ion as sulfide, or in previous slide, you can consider these insoluble salt, for example, silver chloride, silver bromide, lead chloride, lead bromide. Mercury compounds are usually not given in our syllabus, so don't think about this. But remember for your Viva boss. And similarly, if sulfates are there and the compound is insoluble, then these could be there. So insoluble, these are the possibilities of the compounds. Hydroxides. Hydroxide is not the part of the salt, but it is the part of the base. But remember that most of the hydroxides are insoluble, and definitely it is not the part of analysis of not the part of salt analysis. So most of the hydroxide are insoluble except the alkali hydroxide, means hydroxides of group 1, and barium hydroxide, strontium hydroxide. Calcium hydroxide is partly soluble, partial soluble. Carbonate. Most of the carbonates are insoluble except the alkali metal and the ammonium carbonate. All the alkali metal carbonate, for example, sodium carbonate, potassium carbonate, ammonium carbonate is separate, and these are water soluble. Otherwise, all the carbonates are insoluble. Sulfite, it is not the part of our syllabus in most of the colleges. Most of the sulfites are insoluble except the alkali metal and ammonium sulfides. Phosphate. Most of the phosphates are insoluble except the alkali metal phosphates and the ammonium phosphate. And in most of the colleges, it is not given. But remember that it is the part of your viva and your scheme. Similarly, sulfide is also not given in most of the colleges. So what is given? Carbonate, nitrate, chloride, bromide, iodide, sulfate, and acetate. And one more thing, some ions are not given here. Another important ion that is very commonly given in our colleges is carbonate ion, bicarbonate ion, or the hydrogen carbonate ion. These all the salts containing hydrogen carbonate ion are soluble in water. Okay, so this is also one of the important ion, and it is the part of our syllabus. So these different ions, you should remember their formula for viva voce, as well as we will see in later slides that how can we identify these. And one more thing that is not given here is the state of the salt. In preliminary test, first of all, we write this one, and I will show in another video that how to write how to write your experimental description in your examination paper and your journal. So state of the salt is also concerned. If it is crystalline, then it may be nitrate, acetate, chloride, bromide, iodide, or oxalate. If it is amorphous, then it could be sulfate, phosphate, bicarbonate. That is also called hydrogen carbonate or carbonate containing salt. And if it is hygroscopic means some salts absorb moisture from atmosphere and they become wet. If your compound is just like that, then it could be the nitrate, acetate, chloride, bromide, or iodide. This is I-1 of alkaline earth metal, not alkali metal, not sodium and potassium. But it could be of alkaline earth metal. For example, magnesium chloride is slightly hygroscopic. Aluminum nitrate is also hygroscopic. And transition metal, for example, zinc, iron. Deliquescent compounds are also this is the also the same term, the hygroscopic, but what is the difference between hygroscopic and deliquescent? For example, if you take a small quantity of salt in your petri dish or watch glass or evaporating dish, then after some time, what happens? It becomes liquid. It forms the aqueous solution. It absorbs too much water vapors from the atmosphere and make it solution. So such a compound is called deliquescent. And deliquescent compounds are calcium chloride, aluminum chloride, ferric chloride, aluminum nitrate as well. It is deliquescent. Copper nitrate is also deliquescent. So these are the deliquescent compounds which absorb water. Sometimes we may classify them as hygroscopic. So it depends on your instructor whether he is instructing you to make the difference between hygroscopic and deliquescent or not. But in analysis, it is different. So it helps you to identify your given salt easily. So if the state of your salt is hygroscopic, then you can easily understand it could be acetate, nitrate, chloride, bromide, iodide, or etc. And which acetate and chloride bromide could be there? It could be of calcium, aluminium, iron, cobalt. So to identify hygroscopic and deliquescent compound is it makes your analysis easier. And phlegm test usually not carried out as preliminary examination in intermediate chemistry in Pakistan, but remember that it is the part of analysis. And certain cations give specific colors. The red color, this bright red color, is due to the lithium, presence of lithium. Sodium gives golden yellow color. Potassium gives lilac or light purple color. Rubidium and cesium gives shades of blue color. This is the part of our syllabus. Lithium is not the part of syllabus. Sodium is part of syllabus, but usually not given. But in Viva teacher may ask you the color of the flame color of the sodium and potassium. Calcium, it is the part of our syllabus. For group 5 cation, it is very fruitful test for identification of these cations. This is the brick red color, and it happens due to the presence of calcium ion. Strontium gives crimson red color. Barium gives light green color that is called apple green. Copper gives green color flame, and titanium gives yellow color flame. How this test is performed? Listen. Flame test is very fruitful for certain salt, notably their chlorides impart characteristic color when they are heated strongly in the hottest part of the flame. And that hottest part is the non-luminous part of the flame. These colors can be used for identifying the ion. Non-luminous, usually the flame color is little bit like this, the color of the calcium ion. Not calcium ion, the flame of the calcium ion, flame color of the calcium ion. But if you see that this is almost blue or non-luminous. So what we do, we perform this test by taking a wire loop that is made up of platinum. It is made up of platinum. So what we do, first we dip it in the solution containing concentrated HCl, concentrated HCl. So first we dip it here, then we touch this with the salt. It is touched with the salt after dipping because it contains concentrated HCl, and we use the platinum. That's why, because platinum is inert to the acid. So when we touch this with the salt, salt could it can contain any anion, but when concentrated HCl interact with the salt, some of the ions becomes part of the becomes chloride. For example, suppose the compound was calcium hydrogen carbonate. So when you touch this wire loop, this platinum wire loop from concentrated HCl to the salt, so what happens? There is a reaction occurs there, and it is converted into its chloride. Similarly, if it was barium, any compound of barium, then it converts into barium chloride. So actually, why we convert them in chloride? Because chloride impart characteristic colors easily. It can be evaporated easily. So it gives this flame color. I will tell you the detail of the flame test in another video. So you just remember for qualitative analysis that calcium, strontium, and barium especially, and along with this, sodium and potassium. While rubidium, cesium, and titanium are not the part of our syllabus. Copper, in term of Viva, it is in our syllabus, but not in our syllabus. And in this video, in this slide, the flame color of barium looks white, but actually it is not white. It is very light green color. So watch my another video about the flame test, a separate video of flame test I have given you. Now, the classification of anions. Remember that all the anions have been classified into three groups. Group 1 contain carbonates, bicarbonate, hydrogen carbonate, and acetate. Nitrite, sulfide, sulfite, and thiosulfate. These are not the part of our syllabus, but remember these ions for your Viva was. And one more thing, that nitrite is not the part of our syllabus, but in some colleges, sulfide is given in the experiment. Okay. So you must follow the test for sulfide as well. In group 2, chloride, bromide, iodide, nitrate, and oxalate. Usually oxalate is not given in the colleges, but these are the part of the syllabus in almost all the intermediate colleges in province Sindh. And group 3 contains two ions, sulfate and the phosphate. And phosphate is usually not given in your colleges, but you should remember that, and you should remember the distinguishing test between sulfate and phosphate that we will discuss in other videos. Now the second column is showing the group reagent. Group reagent means either you start with dilute sulfuric acid or dilute hydrochloric acid. It reacts with all of them and gives the characteristic observation that you can identify. If any one of these are present, then you can identify from these their particular reactions. For example, carbonates and hydrogen carbonate can be identified by brisk effervescence that we will see in individual videos of the salts. Acetate can be identified by vinegar-like smell. You should smell that. So the group reagent is dilute HCl or dilute sulfuric acid. You can use any one of them. For group 2, the group reagent is concentrated sulfuric acid. And remember that these tests are performed in salt directly. We are not making the solution. We directly perform in the salt. How? You take the salt in your test tube and then add dilute acid in group 1. In when you are dealing with dilute acids, then you don't need to hold your test tube um, with test tube holder. Otherwise, for concentrated sulfuric acid, you need a test tube holder because it is very injurious for your skin. So use the gloves, laboratory gloves, as well as take it, hold it with the holder, test tube holder. And both of these tests are called dry test. Why they are called dry test? Because these are not performed in the form of solution. We take the salt directly. And it is also the dry test. And this is the wet test. So generally, identification of anion or the test for anions are called, the group reagent test for anions are called dry test because we use the salt directly instead of taking their solution. But here in group 3, OS stands for original, O stands for original, and S stands for solution. So we make the original solution, and usually the original solution at intermediate level is made in cold water. Cold water means water at room temperature. But from this slide, you must remember all the ions, whether these are in your syllabus or not. These could be the part of your Viva was. And you should remember that these are called the dry test, and these are performed directly on the salt. And every ion gives its characteristic color. If characteristic observation. If the observation is little bit mixing for two anions, then we have some other test to distinguish them that we will see individually in every salt. So you have to watch other videos as well. This is just introductory video. Now, the classification of cations. Cations have been classified in 6 groups. These are not the groups of the periodic table. These are the groups of the inorganic analysis. And these all the tests are performed in original solution. So the group reagent are there. We add the reagent in the original solution. Why we perform? So the original solution plus these, original solution plus these, original solution plus these. And group 6 has no specific, there is no specific group reagent. All these 4 ions, which are ammonium, magnesium, sodium, and potassium, are identified by their separate groups, by their separate reagents. Sodium and potassium are not the part of our syllabus, but remember that these could be the part of your Viva was. But ammonium and magnesium are given in almost all the colleges. Now I start from the group 1. Number one, all these tests are wet tests because these are performed in original solution. Why are they are called wet tests? Because these are performed in original solution. But why we performed in original solution? Because in almost all these tests, all these chemical tests, we observe whether the precipitates are formed or not. So if you are not making the solution, then it is difficult to identify whether the precipitates are formed or the salt is salt remain there in its insoluble form. So that's why these are performed in original solution. So first group 1 contain lead, silver, or mercurous. But mercurous is not the part of our syllabus. Silver is also not the part of our syllabus in terms of your identification. But in Viva, you must remember all the ions in their respective groups. In group 2, lead. Lead is repeated here because sometimes lead is not identified in group 1. So it can be identified in group 2. Cupric or copper 2 ion, bismuth or Bi3 plus ion, cadmium or Cd2 plus ion. Mercury, tin 2 plus, strontium or antimony, or stannic. These are not the part of our syllabus in any college in Sin. But in a few colleges, cadmium is given, bismuth is also given, and copper and lead are very common. So it depends on your instructor whether he has uh, given you he has kept these salts in the syllabus of his college or not, because it is up to uh, your college whether they keep these or not. Ammonium chloride and ammonium hydroxide is the group reagent for for the group 3 ions. It contains aluminum, iron 3 that is called iron 2 that is called ferrous, iron 3 that is called ferric, and chromium. And usually these are commonly given in every college except the chromium. Some colleges give chromium, but most of them do not give. But remember all the tests for chromium as well. Or you can ask your instructor at your college whether the chromium salts are there or not. And definitely if you have performed practicals at your college, then you must not, it could be in your the practical contents. Ammonium chloride and ammonium hydroxide and H2S. The group 4 contains cobalt ion, cobalt 2 plus ion, nickel 2 plus ion, zinc 2 plus ion. These are very commonly given in different colleges, but manganese rarely given in colleges, but it is the part of your syllabus. And remember that all of these could be the part of your Viva. For group 5, barium, calcium, and strontium are there. And remember that fortunately, these belong to the same group of the periodic table. Calcium, strontium, and barium in group 2 of the periodic table, which are alkaline earth metals. And group 6 contain ammonium and magnesium that we have already discussed. It also contains sodium and potassium ions. And now the group reagent. The group reagent for group 1 is dilute HCl or dilute sulfuric acid. Because we have seen in solubility chart that lead chloride, lead sulfate, silver chloride, silver sulfate, mercurous chloride, and mercuric sulfate are insoluble in water. So if enough precipitates are formed, white precipitates are formed, in any case, whether you are using dilute HCl or dilute sulfuric acid, if white precipitates are produced, then these compound could be there. Because in cation analysis, we observe the formation of precipitates. Almost in all the cases, we observe the precipitates. But sometime when you perform group 1 test by using dilute HCl, lead ions could be there, but they are not observed because not enough precipitates are formed. Because the reason behind the precipitation reaction is the solubility product, and the solubility product of lead iodide is higher. That's why sometime lead cannot be identified in group 1. So you can identify lead in group 2. The group reagent of group 2 is hydrogen sulfide, but HCl is used as a common ion. We will discuss common ion effect in separate video, but remember that the main group reagent is H2S. Or sometime your instructor say that HCl and H2S is the group reagent, but actually it is not the group reagent is that which forms respective uh, which gives the negative ion to form their respective sulfide. So in group 2, all of these ions can be identified by their sulfide. For example, lead sulfide. There could be the formation of copper sulfide. There could be formation of bismuth sulfide. So the group reagent is H2S. And in group 1, group reagent is dilute HCl or H2SO4. You can use either one of them, not both of them. So if you are using chlorides, then the compound or the precipitate would be of lead chloride, silver chloride, mercurous chloride. But I'm not writing because these are not the part of your syllabus. And if you are using dilute sulfuric acid, then there would be white precipitate of lead sulfate. So in this way, you can identify, always perform group 1 first. This is the scheme. Similarly, in anion, you first perform the group 1 test by using the reagents of group 1. If group 1 is absent, no any observation of these anions is there, then you can go to group 2. And very carefully observe the presence of these ions, the reactions occurring between sulfuric acid and the salt. If there's no reaction and it gives no characteristic observation of these ions, then you can proceed to next. So similarly, in cations, first we perform the test for group 1. If group 1 is absent, then we perform test for group 2. And after that, perform test for group 3. So you will take ordinal solution again. And here ammonium chloride is used as common ion. This is the common ion. Ammonium in both of them. So ammonium is used as a common ion. And this is the group reagent. This is group reagent. Because these are identified by their hydroxide. If they give the characteristic precipitates of their hydroxide, then it means group 3 is present. If not, then it means group 3 is absent. If group 3 is absent, then go to the next. And here, what you are doing, again, you are using ammonium chloride and ammonium hydroxide, and we add hydrogen sulfide. Again, hydrogen sulfide is the group reagent. So hydrogen sulfide is the group reagent for two groups, group 2 and group 4. But in group 2, it is in presence of HCl in acidic medium. In group 4, it is in presence of ammonium chloride and ammonium hydroxide in alkaline medium. But the difference is not the alkaline and the acidic medium. Difference is that in this condition, it generates more sulfide ions. And in presence of acid, it produces less sulfide ions because the solubility product of the sulfides of group 2 cations is low. So the small quantity of sulfide is enough. So in this way, we can separate group 2 and group 4. And sometimes if the HCl is too much dilute, means less more dilute than the requirement, then there would be more sulfide and it may give the false positive test. False positive test means मुमकिन है कि वहां पे ग्रुप 2 का कोई मेंबर मौजूद ना हो. So it is possible that there is no cation of group 2, but it gives black or brown precipitates because these ferrocine, ferricine, chromiamine, cobaltine, nickeline, these can give the black or brown precipitate here if there is more sulfide. So HCl is used as a common ion to suppress the dissociation of hydrogen sulfide. Anyway, I will tell you in detail another video of the common ion. So the group reagent for both of these group is H2S and it is also H2S. But here less sulfide ion are required and here more sulfide ion are required. So that's why we can analyze in a better way. Group 5, again the ammonium chloride and ammonium hydroxide, but the group reagent is ammonium carbonate. And these are the 3 ions. They give white precipitate. All of them they give white precipitate. So we have to perform the distinguishing test for them as well. And again, these are used as common ion. And for group 6, we will see the individual test. So that's all for this introductory video. Then we will see in detail later on.